as 8x cubed minus, well, plus 1/2 x to the minus 2 plus 0. This is your derivative. And you can see that that is
Yep.
what a match there for what's there. So we should skip 7 and 8
Okay.
and come back to them
That's fine.
and go to like 11, 12,
Okay.
and 13 if you
Yeah,
want.
that works. That's fine.
Okay. Right. So 11 is actually a really, I think we did this with derivatives too. They had kind of this like sequencing where you do rewrite. There's a rewrite step, and the rewrite step refers to this part, right? It's really
Okay.
x to the 1/3 power. Okay.
Right.
So it's the integral x to the 1/3 dx. So a lot of students ask this without giving a bunch of explanation. These are always paired together. So you cannot have this integral symbol, which I don't know what you want to call it. It's like a fish hook or I don't know, something, whatever. It always goes with a dx or a d variable, whatever your variable is.
Okay.
You have to have them there together. Now, when you take what's called the antiderivative or integrate or the integral, whenever you do all that, you no longer have this right here. Okay. So there's a rule for this. The rule for integral x to the n dx is you add 1 to the exponent instead of subtracting 1. So remember how last, when you take a derivative, you would subtract 1.
Yeah.
Well, now you add 1, okay? And then you divide by the new exponent. Plus c.
Okay.
So plus this constant of integration, basically. So it would be good for us to do a couple examples. Like let's say it was the integral of x cubed dx. You would add 1 to the exponent and then divide by the new exponent. So this becomes x to the 4th over 4 plus c. You add 1 to the exponent, divide by the new
Okay.
exponent. Does that make sense?
Yeah.
So it works for negative exponents. It works for fractional exponents. So that's what they're trying to show you here. So you would add 1 to the exponent and divide by the new exponent. And this is where you got a little bit of, I don't know, not even college algebra, just like, comfort level with adding
Right.
fractions. So this ends up being x to the 4/3 over 4/3. Notice the exponent and the denominator are the same. And you got to remember, well, how do you deal with a fraction? The fraction, when you flip it, 3/4 x to the 4/3, like that.
Okay. Yeah, that makes sense. Okay.
Plus
Should we?
c. Plus
Okay.
c. So there's always this constant integration. You may be wondering, well, why is that there? The reason is kind of what we were doing in the first two examples of this. The derivative of a constant is 0. So you can always add a constant because when you take its derivative, the constant goes away. And that's why you have that. So we should do number 12 next if you'd like.
Yeah, that's fine.
Okay. So number 12, is, again, that rewrite. So this constant is not important. Like it's really the integral 1/4 times 1 over x squared dx. And then that 1/4 can actually come out of the integral. That's one of the properties you'll see later on, but it's x to the minus 2 dx, like that. So it's up to you if you want to bring it out or leave it in terms of the integral. It's kind of easier, but it's totally up to you if you want to do that.
So you would just take it out and then just have it multiplied at the end, or
Yeah, you can leave it up till the end, and if you want. So So the integration is, they're really not giving you enough room to that. So let's just kind of work on it here. So you're going to add 1 to the exponent,
Right.
divide by the new exponent. And like you said, that 1/4 is just coming along for the ride.
Okay.
This becomes x to the -1 over -1 1/4. So you combine the 1/4 and the -1 to become -1/4, and then it's 1 over x. So to make it pretty, you would, and they actually are functions called, make pretty and in math, the math world, but it becomes -1 over 4x like that. Well, maybe that's over here, -1 over 4x plus 4x plus c, if you want.
Okay.
So the instructor wants the final answer over here.
Right.
You gotta, because of the way I've seen your quizzes formatted. By the way, do we need to go through any of those quiz questions from over the weekend?
No, they were fine.
Okay. You you might see like variations in the way it's presented to make it, like, you just want to be careful. Like it might be written like this: -1 for x is correct plus c. I'm sorry, that is not correct. For x like that is correct. With the x's on the outside, it's not correct. So there could be a few little things there. Think about when you're looking for your answer.
Okay.
Okay. Next problems I'm seeing are 15.
Yeah, just a sec. Yes, 15, 16, yeah.
These are all good to do. Oh, excuse me. There's at some point I sent you a table of derivatives, and then it had integrals, which I didn't mention, but it does. And we need to know all those integral rules as well. So I'm going to put that in the chat here in case you don't have that. The integral is on page 2. Try to
Maybe I
refer to that.
downloaded it, but yeah, I'll check it again just in case.
All right. There it is. Why is it so difficult today? All right, there it is. So let's see here. We'll look at number 15. We'll try to apply these rules here. Uh, Okay, so in its most basic level, what you can do here is you can take the integral of x dx plus the integral of 7 dx. Okay. So it's kind of like a distributive property, if you will, on that. You will eventually not do this, but for just simplicity of like trying to explain the different types of integrals, I'm breaking them apart here. So this
Okay.
first one is that power rule. That's the integral x to the n dx becomes x to the n plus 1 over n plus 1. Could you tell me what the integral of this is over here on the left, please, based on that simplified
Yeah.
form?
So it'd just be x to the 2 over
Yeah, over 2.
2. Yeah.
Like 1/2 x squared. Good. Very good. Now, the next one, like I mentioned, you can bring that constant out. So you can actually write 7 integral dx,
Okay.
and the integral dx here is always okay. Now, if there's a constant in front, the constant comes with it. Now
Right.
that's a different C. So actually I should probably use a different letter here, like K or something. I don't know if that's confusing. Use K. Okay, so this becomes 1/2 x squared plus 7x. There's always, always, always a constant of integration. So that's something to look forward on a quiz. Like letter A would be just this part on the left, and then letter B would be the one that says plus C. You have to always write this constant of integration.
Okay.
All right, so why don't you try number 17 for us? And let me know your final answer. If you have questions, then we'll go back and do 16, which is a little bit different.
X to the 6th power over 6 plus X plus C.
Very good. Very good. Okay. So 16, the minus doesn't really matter. You can treat this as integral 13 dx minus integral x dx, or you can put that subtraction like inside and make this a plus. It's kind of up to you how you see it, but this is 13x minus 1/2 x squared plus c,
Okay.
like that. Okay. All right, so let's have you try number 18 on your own here. This is a good, just see if you got everything down here. Try to simplify your fractions as much as possible if you can.
Not X to the 9th power plus X to the 2nd power plus C. Or I mean minus X to the
Okay.
2nd.
What about this last one here? Minus,
Doesn't that just, oh no, because you add it, okay. Um, plus 6.
you gotta get your signs right. That
Minus
minus
minus 6.
6x minus
Yeah, no,
6x.
yeah, minus 6x.
Okay, plus c. Let's have you this what was good here, because this is the common thing you see on testing quizzes is the, ends up being x to the 9th over 9, which have that 9 in front and they cancel. Same thing with here. So let's try let's have you try another one here. Let me make one up here. Integral of 2 minus 3x plus 4x squared. Yeah, so go ahead and give this one a try, please.
Two minus 3x squared over 2 plus 4x to the 3rd over 3 plus C.
Okay, so yeah, we're still missing here. Integral of 2 dx. Integral of 2 dx. What we did an example like this, the integral of dx is always x, and if you have a constant, it's the constant times x.
Oh, 2. Okay, so 2x then.
2x, yes.
Okay.
Minus, now the other ones you're getting 3/2 x squared plus 4/3 x cubed dx.
Okay.
Or plus c, sorry, plus c, not dx. All right, so let's have you try one more here. Like, this is kind of when we first learned derivatives. It's really important that you be able to get these down. So
Right.
try one more here before we move on to something else.
So x to the 5 halves over 5 halves plus x squared plus x squared over 2.
The last one is the integral of 1 dx.
Right. But doesn't it become then x squared over 2?
The integral of dx is just x, and then if you have a constant, which in the case would be a 1, it comes with it.
Oh, so it just becomes x then.
Yes, yes.
Okay.
Now, you do have to simplify the denominator here. Let's see. So how does this simplify on the left?
Um, the fifth root of x over 5 halves.
Just the fraction part. So what I'm asking is like, if you have 1 over a over b, it becomes b over a.
Okay. So
So this becomes 2/5, because this is how it's gonna be presented in your quiz, is 2/5 x to the 5 halves plus x squared plus 1x plus c.
okay.
Okay, so like we shouldn't even go on from here until like we get this down, because it's like, and so the ones you're really struggling with, which I mean, it probably is true. Like, what is the integral of 7 dx? Let's have you just try something really, really basic here.
7x.
7x plus c plus c.
Yeah.
If it's 5 times the integral dx, what does that become?
5x plus c.
5x plus c. Good. Yeah. And this is what I'm trying. Yeah, this is what I'm trying to make sure is clear here. So before we move on to the more difficult ones, and you see you're going to find, and the good news is you're moving into the last part of the course. I mean, this is, basically you're done after this. How many more weeks in your class, by the way?
I think we go until August 8th, something like that.
Oh, wow, so you do actually have, and this is a
Yeah.
brief calculus class, or is it a calculus 1 class?
It's like I think it's calculus. No, it's like geometry and calculus, something like that.
Okay. Okay.
Analytical geometry calculus
Yeah,
1.
the reason I'm asking is because you have the time to go through more topics here, but the typically the course ends after integration. So maybe you're doing what they call brief calculus, where you hit all the topics, you just don't get them in much depth. So go ahead and try this one for me, please. You don't mind?
X to the -2 minus 5x to the -4 plus c.
Really good, really, really good. Okay, yeah, so the next types of problems we're gonna see here have to do with roots and like division. So just a few reminders on exponent rules, because I think that's maybe where this is most difficult. Like, let me give you a couple of problems here to look at together. You have to know how to rewrite them, and for now, you really do want to rewrite them with the exponents in the numerator. So this becomes -4x to the -3 minus 8x to the -5, like that. And that's how you want to work through the integration. Okay. You don't have to do it on this one, but here's another problem you might see. Integral -5/3 cube root of x squared minus 5/2 fourth root of x dx. You would again want to write this as -5/3 x to the 2/3 power minus 5/2 x to the 1/4 power. You'd want to rewrite it before you take the antiderivative or integral. And if you probably remember us doing that in with derivatives as well.
Yeah.
The same thing here. So for 21 here, I'm going to put in front of you, this is from your assignment here. You can do the integration or you can rewrite it and I can check, but really important that you
Is it not just x to the 2/3 plus c?
yes. Well, no, that's the rewrite. You still have to integrate. You still have to integrate now. Like you rewrite it and then you integrate.
Oh, okay. So that's what you would get, and then you would have to, okay. So it'll be 3/5 x to the 5/3 plus c.
Perfect. Perfect. All right. So here's, might as well have you try 22.
Four-sevenths x to the 7/4 power plus x plus c.
Yeah, really good. Okay, so I think you've got that down. We're gonna do 26 together next because this is like kind of another classic, problem you would see on a test or quiz. So you currently don't know enough to be able to integrate this as is. So what you have to do is some algebra. You have to do something, something to make this better. So you actually end up dividing each of these by x to the 4th. And so this ends up being 1 minus 2 over x squared plus 5 over x to the 4th. And then you rewrite with just the exponents. So plus 5x to the -4. And again, you still have not integrated. Like there's this suggestion that um, you've done some calculus, but not yet. So now you're truly ready to integrate. Would you integrate this for us, please?
x plus 2 over x plus 5x to the negative third over negative 3 plus c.
Really good. Now you would want to move this negative out here, like it would probably appear here.
Yeah, I was gonna
Um,
ask how to simplify that one because I wasn't sure.
Yeah, so it'd be I'm sorry, minus 5/3. And the x could come down here. It could
Right.
stay as negative. It could be x to the -1 in the middle one. There's a lot of ways that these could be rewritten.
Okay.
So you gotta be like on top of um,
Right.
that. Okay, so here's one for you to try a little more on your own. 25 here. As a reminder, the square root of x is really x to the 1/2. So you want to first divide each of these by 1/2, cancel your exponents or modify your exponents, and then take your antiderivative. So go ahead and work that out. Just see where you're at. Maybe you got it. Maybe
X plus 14 x to the half power.
okay. Yeah, just based on answers, I'm gonna probably need to look at this a little more. So it's x over x to the 1/2 plus
Right.
6 over x to the 1/2. So there's really a 1 up here. So it becomes x to the 1/2. 1 minus 1/2 is the 1/2. 6x to the -1/2. Do you have anything like this written?
Yeah, I just didn't have, I had the first one written as negative half also. So I had x to the negative half plus 6x to the negative half. Because
Okay,
it,
okay, so yes, okay, so when it's positive, it stays in the numerator.
yeah,
This one you bring up and it's negative. So why don't you retry it from here? You're gonna get two separate answers for it. I mean, something, this one and then this one on the right.
2/3 x to the 3/2 power plus 12x to the half.
Plus
Let's
C.
see.
Yeah. Excellent. So that's really a good um That's good. That's a really good one to be able to do. So from here, it moves on to kind of the rest of that page of rules that I gave you. Um, so what I mean is let me just snip it in to be clear, because some of these, like we've actually covered everything that's in the top part of the integration rules here. Like I know these probably look really bad and confusing, but it's some of it's common sense. Like a constant times a function is the constant. The derivative, you can split them apart, that's what we've been doing. There's sum and difference, things like that. And then we've done the common integrals. We've done a lot of the common integrals, but now we're moving into like the specialty ones, kind of like with derivative rules, there were these specialty derivative rules. And there's a bunch you're gonna have to memorize or remember having your reference sheet. So like if we move to a problem like 32, this is where you've got to say, okay, first thing is it's different variable besides X, which I get that could be super uncomfortable. So you can change it to X. Like if you really don't like that it's a theta, you can make it an X. All right. So now this is integral X squared dx plus integral secant squared X dx, like that. And then, okay, the one on the left here, well, that's power rule, right? We've done a bunch of these. What would the one on the left be? What would it become?
X to the third power over 3.
Right, so 1/3 X cubed, or like you said, X plus. Now this one on the right, you've never seen that before, but there is in your integral table, there's a rule. The integral of secant squared u, and u refers to the variable, becomes tangent of u plus c. So this becomes tangent of X plus C. And I don't want to give you the wrong impression here that you can just look them all up. It's not that simple. I mean, I wish it was that simple, but it's not. So just keep that in mind. Like some you'll be able to look up, some will require more effort depending on where you are in the course. Questions on that?
Nope, that makes sense.
All right. So 33, really similar to 32. You break this apart. You're like, all right, it's the integral of secant squared theta d theta minus the integral of sine theta d theta. Now you got to go look for these. So the first one we know from the previous problem, it's tangent. And you might remember, okay, the derivative of tangent is secant squared. Okay. Now sine is one of those you're going to want to remember. So if you recall from before, sine theta's derivative with cosine theta, cosine's theta's derivative is minus sine theta, minus cosine theta, and then it comes back this direction if you're taking a derivative.
Right.
If you go the other direction, it's the integral. So the integral of just sine theta becomes minus cosine theta, which it is in that reference sheet that I sent you.
Yeah, I see that.
Okay, so you know, say plus c, you combine some sines, so tangent theta plus cosine theta plus c, like that. And there you have it. There's and so they're you're kind of limited on what they can ask you to do because you don't know enough to do many of these. So they like right now you're in this place in the course where they're trying so hard to give you problems that you can do, but they're they all go back to something in your book, in your table. It's like 36 integral of 4x dx minus integral cosecant squared x dx. What would the one on the left be?
4x squared over 2. So 2x squared.
2x squared. And then now it's like, do you remember whose derivative is cosecant squared? It's related to whose derivative is secant squared. So derivative of tangent is secant squared. The derivative of what gives you cosecant squared? Well, that was cotangent squared. I'm sorry, cotangent, not tangent squared. And that's just another one that you can look up in that table. So there is the expectation that you know this table. Now, I made one small error here. Let me snip this in. The integral of cosecant squared is actually negative cotangent. So there's a negative here to go with it. So that because you're bringing this one down, this negative comes from the integral. The second one comes from the integral. So that's 2x squared plus cotangent x. Let's see. Okay, do you want us to go any further here?
No, that's good for today. That's fine.
Okay, all right. So we will stop here. We've got our lesson scheduled for tomorrow at